Alright, today we return to practical 8-9. Actually, we're doing practical 9, beginning from question. We finished question 3, so now we're going to go to question 4. Alright, so question 4. Take the vector multiplication code from the practical arrays and structures and modify the code so that the multiplication takes part in a function. The call to the function should be, this is the call to the function, and where vector 1 and vector 2 are two floating point arrays of values, and length is the number of elements in the vector. Use values from the 2, 3 element vectors used in the previous practical and check the correctness of the result. Alright, you don't have to go and look for the code. I'm going to give it to you. It's already in Moodle. Alright, where do you find it? Actually created a file by itself. Alright, it's called vector multiply. So you can just download vector multiply. So before we do that, we will do the skeleton on our own. Okay, how do we do the skeleton? So let's open up Dev C++. So you remember functions have 3 parts. What are the 3 parts? Do you remember? Can you recall? Right, the first part is the function declaration. Right, I'm going to just write it down. Function declaration. Function declaration is above the main. Okay. Next part is, what's the next part? Function call. Function call is within the main. And finally, we have the third part, which is the function definition or the function description. Function definition is below the main. Right, so these are 3 parts. So let's look at our question. What did they give in this question? They gave you the function call. We actually can get a lot of clues from the question itself. So what is this? It's a function call. If it is a function call, where should it be? It should be within the main. Right, so let's build the main function. Okay, int main. Right, open curly brace. So this is where the function declaration, function call is within the main. Okay, now what did they say about what in the question? Let's look at the question. Okay, vector 1 is a floating point array, right? And the length is the number of elements. Number of elements normally is an integer. Okay, this is an array size. Okay, so first thing is we're going to do a function declaration. Okay, now how do you normally do a function declaration? You have the first step for doing function declaration is we need to write the name of the function. Okay, this is the name of the function. What's the name of the function? Multiply vectors. So open bracket. Now what are the 2 data types of the variables that are being input? What is the data type? Vector 1 is what data type? You can see from the question. Vector 1 is a floating point, vector 2 is a floating point. So float, comma, float. Alright. Now length is what? Length is number of elements in the vector. Okay, or array. So number of elements is normally an integer. Okay, so we can have that as an integer. Okay. Integer, alright. So now result should be a float. So normally one vector multiply another vector, you get a single scalar value. So the output is result, data type is float. So we can actually do a declaration here. Float result. Right? And we can also declare float vct1. Alright, when you declare, now according to the question, let's read the question. How many elements are there? 3 elements. 3 elements means size 3. So vector 1 has size 3 elements, and when you declare a variable, you can assign straight away. I'm going to keep it simple. Just use 1, 2, 3. You don't have to use any complicated numbers. Alright. Alright, so after we have declared vector 1 and vector 1, we have to declare vector 2. So some of my students might ask the question, why are we declaring the variable? You see, we are doing what? We are doing multiplication of vector, right? So you cannot do multiplication unless you have some inputs. So this will be our input. 4, 5, and 6. And you've seen this before. We have done multiplication vector, right? So how to do vector multiplication? 1 times 4, 4. Plus 2 times 5 is 10, 14. Plus 18 is 32. So that is the value of result. But instead of doing the calculation over here, alright, we're going to do the calculation inside the function. Now there's one thing interesting. This data type vector is a array, right? So when you want to send an array to a function, say you're calling the function, yes? What's the name of the function? Multiply vectors. This is called a function call. And when you call this function, you are sending vector 1 and vector 2. Vector 1 is an array, vector 2 is an array, and this is the length. So length is normally an integer because it's an array, size of the array. So we can say the value of length would be, if you look at the question, it says 3 element. Okay, length is 3. Right, length is 3. So now we have, you see, the way you do the declaration, there's a special format for it. Okay, where do we learn this format? It's actually in your lecture slides. So if you open up your lecture slide, you go to lecture 9, single one page. So you go to lecture 9, okay, lecture 9, page 7, okay. So dealing with passing arrays. When you hear the word passing arrays, that means you are calling the function and you are sending the array to the function, right? So there are 3 methods of declaration of a function which has an array in it. So what are 3 different methods? So the first method is you can use the variable. This v1 is the name of the vector or the name of the array, followed by a blank bracket, v1 with the size, or you can use with the asterisk. For those of you who know that asterisk is used in pass by reference, you need to know that all arrays are passed by reference by default. So you don't have to use the ampersand symbol. Ampersand symbol is address of. You don't have to use ampersand symbol. Without you knowing, it is passed by reference by default, automatically. Alright, let's look at the first example. So there are 3 methods. What are 3 methods? When you put a variable inside a function, you can use with an empty bracket, or with the bracket with a number, or you can use an asterisk. So there are 3 methods. So this is the first method. Okay, this is the second method. What's the difference in the first method and second method? First method, empty bracket. Second method has the size inside the bracket. And the third method uses a asterisk when you declare the variable. So the difference, what are the 3 differences between the method? Is actually the way you write the array. So you can choose one. I highly recommend the first method, simply because if you look at your description or definition, over here also has an empty bracket. So if you use this empty bracket on top and empty bracket below, it will help you to remember. You have less things to remember. Okay, so now how do you do that? Now let's have a look. So what is the name of the array? vect underscore 1. Now you can use the size, or you can put it empty. Alright, so what's the next? What is the next array that you're going to send to this function? Underscore 2 empty bracket. Now for the int, you have an option. You can put length over here. Alright, this is acceptable. Or if you want to leave it empty, also acceptable. Now one more thing that is missing. At the end of the statement, you must have a semicolon. So what is this? This is called the function declaration. What happens before the function declaration? You need to have the include statement stdio.h. Alright. Now what's missing? What are the third part of the function? So you have the declaration, alright, And also, when somebody returns a variable, you see you call a function, you send the data, vector 1, vector 2, then you do some calculation, right? There should be a return, right? So that you have a result here. So if this, see, when you see the equal symbol here, whatever the output of this calculation will be sent to result. Therefore, you have to print out the result. So printf, what is the data type of result? Float. So the result is, okay, percentage f, right, comma, result. Okay, let's do the function definition. So how do we do the function definition? We know this is the function call. Where do we find the function call? The function call was given to us from the question itself. So we take the function call. Okay, we copy the function call from the question itself. Alright. So function call, first thing you need to know about function call, there's no more semicolon. In fact, it's replaced by a curly brace. Okay, this is the function definition. I'm just putting a comment there. Anytime you see blue with slash, it's a comment, it's a notes, right? If you're wondering what this thing is, actually notes. Why is it a note? It's that you can see it, but the computer cannot see it. So next, remember, what is the news? The top reflect the bottom, right? So float, when you see a array, put an empty bracket. Float, empty bracket. Alright, and int length. Alright, next. Do you guys remember how to do vector multiplication? If you've forgotten, you can just get the calculate, you get the code from here. So if you go to Practical 8.9, go to vector multiply, just take the part which is related to the calculation. You can see it over here at the bottom. Alright. Alright, when you see it, so first you declare a temporary location, you declare I. So now you have a loop. Alright, when you have this loop, you have to multiply. Okay, and you have this equal symbol. This is a short form. What is the long form for this? Equal, okay, temp plus. So what happens is, when I is 0, vector 1, 0 is 1, vector 2, 0 is, vector 2, location 0 is 1. So 1 times 4 plus 0. So every time this thing keeps on repeating. Remember, how many times does this repeat? This repeats 3 times. 0, length I is 0, I plus plus is 1, and finally is 2. Because the value of length is 3. So 0, 1, 2, because arrays start from 0. Okay, so starting value first is 1 when I is 0, vector 1 0 and vector 2 0 is 1 times 4 plus 0, you should get 4, then plus 2 times 5 is 10, 10 plus 4 is 14. Next, vector 1 location 2. Remember, you see this array, this is vector 1 location 0, this vector 1 location 1, and this is vector 1 location 2. Why start from 0? Because array, when you start counting elements, the array start counting from 0. So you add up. So finally, vector 1 location 2 is 3, vector 2 location 2 is 6, 3 times 6, 18, 18 plus 14 is 32. So therefore, you return the value of temp. Remember, this is a function with a return. What is the data type of temp? Temp is a float, right? So you have to write the float in front of this. So let's say if the temp was an integer. Okay, I like to show this. If temp was an integer, you have to write integer in front of the function. But in this case, temp is a float. Why is temp a float? You might ask a question. Remember, we have two vectors. Both are floating point vectors. If you multiply the two floating point vectors, you get one single scalar value, which is a float. Alright, but of course we are not using float values. We're using simple values just to show the outcome. So let's compile this code. Let's save this. So this is question 4, I guess. Save it as .c, and this will be lab 9, question 4. Compile, run. Right, so it's 32. How do you know it's 32? 1 times 4 is 4, plus 2 times 5 is 10, 14, 14 plus 18 is 32. Now, what are things you need to take away? You need to know that functions have how many parts? Declaration above the main, call is within the main, and function definition is below the main. The idea of a function is that you can call the function as many times as you want. Every time you call a function, you can actually change the values in the array, and you can get a different result. So the idea, it becomes like a tool. A function is like a tool. Every time you call it, you can send a different array. All you need to make sure is that the array, when you call the function, you must make sure you send a variable that have the same data type. So vector 1 is a float, and vector 1 over here is also a float. And when you use arrays together with the function, so make sure there is a format you need to follow. You can read through the lecture slide, and there are 3 methods. I choose the first method because I feel the first method is the easiest to remember. How do you know it's the easiest to remember? So when you declare empty, when you use the definition, also empty. So that's all. Okay, so that's how you solve the first question. Alright, the answer is 32. Alright.